Alright, here's a presentation of the element hydrogen, which is the first element in the periodic table. The hydrogen atom consists of one electron and one proton, which makes it a stable atom. In the nucleus here, you only have one proton and 0 neutrons in this isotope, which is the most common. And out here in the outer shell, you have one electron and only one outer shell. And this is why the hydrogen is definitely the lightest element of all the elements in the periodic table. And what's unique about hydrogen is that it's very combustible and it reacts easily with a lot of stuff, especially oxygen, which explodes in the air. Here's an example of the hydrogen molecule H2. As you know, hydrogen only has one electron in its outer shell, so it's not stable. It has not completed the octet rule. But if it makes a covalent bond with another hydrogen to make the molecule H2, they share these pairs of electrons, and it makes it stable since it has 2 electrons in its outer shell. And that's why you find hydrogen molecules as H2 naturally on the surface of the Earth. And here we have an example of hydrogen in a compound, which is very known and very important for life here on Earth. It's called H2O, and you also know it as water. As you can see here, hydrogen has 1 electron in its outer shell, and oxygen has 6. So the hydrogen wants to donate, each hydrogen donates 1 electron to the oxygen, which needs 2 electrons for it to become stable. So these donate 1 each with this ionic bond, and therefore these are positive, and this one gains 2, so therefore it's negative. And the charges here, it's a bond between them since they're attracted to each other. That's why it's H2O, and it's, they have this ionic bond. It's an ionic compound right here. And these are all the hydrogen isotopes, and they exist free naturally. And here you can see it's heavier since they all gain weight. Here's the first one, protium, which we had a look on before. It has 1 proton in its nucleus and 1 electron in its outer shell. Therefore, it's stable. And it has the mass of 1 unit. Here you have deuterium, which has 1 proton in its nucleus and 1 neutron, and also, of course, 1 electron. And this has double the mass of this one since it has 2 units, because the neutron weighs a lot. And tritium has 2 neutrons and only 1 proton and 1 electron. And of course, they all have 1 proton since that's what makes it a hydrogen atom. Tritium is actually radioactive, and that's why we don't see a lot of tritium on the surface of the Earth. It has a half-life of 12 years, which means after 12 years, half of it has decomposed to another element, which I believe is helium, since one of the neutrons shoot out and it gains 1 proton and becomes helium. But these 2 others are believed to be stable. Well, some people have a theory that protium is actually radioactive, but we cannot confirm this since its half-life is a massive number, which we could definitely not confirm. But here you can see on this thing, you can see how much of each isotope there is naturally, and 99.9%, which is basically everything, is protium, and only 0.01% is deuterium, so that's not a lot. And there's 0 tritium, which I believe is because every time there exists tritium, it gets decomposed into helium, and that's why there's no tritium, which is super heavy. Here's a reaction with hydrogen, which is very common. It's when hydrogen gets lighted and it reacts with oxygen. So here you give it a little energy, like a lighted match. As you can see, the reactants are H2, the molecule, and the oxygen molecule, and they are in the gaseous state in the air. And when you light it with a match, hydrogen reacts with oxygen and explodes, which gives water and a lot of energy, which are the products. And the reason that it explodes is because this reaction gives a heat. It gives heat when it reacts, and then it keeps becoming warmer very quickly, and which therefore is an explosion. And this reaction is so good at giving energy that it's actually used in rocket ships to take off. You have these two containers, one with liquid hydrogen, which is super cold, and then one with liquid oxygen. And they're very pressured, so they don't take up a lot of space. And then you make these two react and give out water and loads of energy. And it's a very clean form of energy since there's no carbon dioxide that comes out of it. And here we can see hydrogen's other daily uses, which is this compound right over here, hydrogen peroxide, which is used in hospitals to clean wounds and clean stuff, sterilizing stuff so the bacteria don't spread. And here we have the air balloon, which needs a light gas to float in the atmosphere. And hydrogen, since it's the lightest of all elements, this is very useful, except that we now know that it's very highly flammable, that it explodes easily if contact with fire. And well, you need fire to make the air hotter so it raises. So yeah, we don't use hydrogen that much, but you can use it since it's lighter than the atmosphere of the Earth. And now I would like to show you a video which explains this reaction, or well, it shows this reaction right over here.
Let's arm the circuit. 5, 4, 3, 2, 1. That was more like lovely.
As you just saw, he he used an electric match, and then he turned it on, which applied a bit of heat to the balloon, which burned a hole in the balloon, and then the hole was filled with oxygen. Well, the hydrogen reacted with the oxygen to do this reaction, which gave out water and a bit of energy. And the energy, which is in the form of heat, makes the reaction go more fast and makes an explosion, since it speeds up very quickly with these. It starts out with a few molecules doing the reaction, and then suddenly it's all of them at once, which gives this explosion. And I believe you can see it in slow motion in any second. As you see, the reaction goes so quickly that it's like the flames the flames burn out quicker than the balloon even explodes, which is very fast. Yeah, that's all I have to say about hydrogen.